Anytime you learn about logarithms, it's inevitable that you're going to get into story problems, and this is really what the logarithm's good for. It's for these story problems that deal with real world situations. I'll try to get you a couple of those tomorrow, ones that really hit home. So here's some examples on page 8 of your notes. And I really should switch the order. I like this third example for the best one to start with, and then we'll look at the other ones after that. So jump down to this third example. Say the population of a town, Lagonia, is 1 million, and it's increasing by a rate of 12% annually, not continuously. How long will it take for the population to double? So issues of population growth, population control. Yeah. So when it comes to exponential growth, there's one formula that you use a lot, and it was we use it a little in this chapter, but more in your previous chapters about exponential growth, and it was y equals ab to the power x. A being what you start with, b is the growth factor, what you're multiplying by over and over again, and then x is how many times you multiply by that growth factor. So let's fill it in a little bit. What you start with, A. So if I'm looking at this population, it says there's 1 million people. So I'm going to leave myself some space here and say 1 million, that's with 6 zeros. It's increasing by a rate of 12%. So 12% we all know is 0.12. The problem with multiplying by 0.12 is that you don't get bigger numbers. You actually get smaller numbers when you multiply by a decimal. So if we want to actually grow by 12% and not take 12%, we need to slap a 1 in front of it. Now that will be 12% growth. We know that we want it to double, so it's going to start with 1 million and it's going to end up with 2 million. But what we don't know is x. And anytime you don't know what the variable is and it's in the exponent, that's what the logarithm is good for. So one of the biggest mistakes that I see is that people dive right in and they try to log the whole problem right away, and you can't do that. You have to identify the thing that actually has the exponent first, and that's what gets logged. Just like in your homework, you had to figure out what had the x that was due for today. Similar idea here. So anything that's here, it's in front of the thing with the exponent, needs to be gotten rid of, and you just get rid of it by doing the opposite. So we're going to divide by 1 million, because it's multiplied there. Divide by 1 million, and it's gone. Divide by 1 million over here as well. So we should have here 2 equals 1.12 to the x. And now we think to ourselves, hey, how can I get that variable to be down so that I can deal with it? It's not division. That's what the log is good for. Log this side and log this side, and we're going to use that property that we've been using over and over again. When you log something, you can take the variable and put it in front. So this actually says log 2 is going to be equal to x log 1.12. Now that it's down, you can just solve it using division. So we're going to go log 2. We're going to divide both sides by log 1.12. And we have it, log 2. Oops, turn it on, log 2. Make sure you close the parentheses. We talked about that. Log 1.12, divide, and you get 6.1. That answer is going to be in years. So it takes 6.1 years. So not too bad when you use the log. Also, something that comes up often is the idea of half-life. How long does it take for a substance to cut in half? You guys have talked about this in science, and now here it pops up in math again. So diapers have a half-life of 200 years, meaning you throw that diaper in the landfill, and how long does it take for that diaper to cut in half? Well, 100 years or 200 years later, however many pounds you threw, only half of it will be gone after 200 years. So what just happened is we took time and chopped it up into 200-year segments. So here's the question. How long will it take 100 pounds of diapers to turn into 35 if we take time and chop it up into 200-year time periods? Well, we'll start out with y equals ab to the x and just start to fill it out as best we can. There's one little wrinkle at the end. So a is what you start with, and it looks like we start with 100 pounds. 35 is what we end with, so that's going to be 35. Now let's think about what's our growth factor going to be, or it's actually a decay factor in this time. It's getting smaller. So what number are we multiplying by over and over and over again? Well, we're multiplying by 1/2. Now how many times are you multiplying by 1/2. That's what we have to try to figure out. Well, pause it 1 sec and solve it the exact same way we solved this bottom one, see if you can figure it out. I'm going to divide by 100 first and get 0.35 is equal to 1/2 to the x. That's where you can slide a log in there and have log 0.35 is going to be equal to x log 1/2. Now we're just going to use division. Divide both sides by log 1/2 and we should be good. We have log 0.35, always close it off, divided by log 0.5, and you have 1.5. And you're like, 1.5 years? That doesn't sound right. Years, we'll put a question. Wait a minute. Let's look at the problem. After 200 years, 100 pounds would become 50 pounds. It would cut in half. So how is it that 100 went all the way, not to 50, but all the way to 35 in 1 year? That makes no sense. Well, if you remember what half-life does, it takes your time and it breaks it up into not years, but chunks of years. So when you have a half-life, that means our time is divided up into 200-year segments. So I'm not telling you that 1.5 years has gone by. I'm telling you that 1.5 of these time chunks has gone by. So 1.5, each one of those is worth 200 years. So I'm going to multiply and get roughly 303 years. So the last thing that you have to do is just multiply by your half-life time. All right, pause it. See if you can do that second example all by yourself. All right, we got y equals ab to the x. Let's see. Percent is a little bit different. It doesn't say how many pounds we started with, but we know when we chuck them in there, we have 100% of what we started with, and we're going to get down to 22. Now, if you'd like to use 0.22 and 1, that will work as well, and I'll show you in just a sec. 1/2 to the x. So we're going to do this. We're going to divide by 100 and divide by 100. So that's where if you use 0.22 for 22%, ends up being the exact same. If you use 1 for 100, you'd have 1 times 1/2. So that would be the same. So we'd have 1/2 to the x. This is where the log comes in. We have log 0.22 is going to be equal to x log 1/2. Use division. Log 0.22, close it up, divided by log 0.5, and we should get 2.18. Once again, 2.18 years? Well, no. It would take 15 years for the books to go from 100% to 15%. So we know that this is 2.18 of those time periods, each one being worth 15 years. So we'll go times 15 and know that it's 32.8 years. All right, last thing I want to show you is kind of off topic, but helpful anyways. How can you do a log on your calculator that has a base other than 10? Like right here, if you hit log, whatever, 20, that log is a base 10. Well, the other ones are actually on your calculator. If you hit math, if you have a new calculator, hit math and go down to, let's see, letter A. So hit math button right here, go down to A, you have log base. Log base, you can just fill it in with a 7 and a 25. So those options are right on your calculator. You can do that as well. If you don't have a new calculator like this, I'll show you the process, explain it to you, and then show you a shortcut so you can do it fast. So we would put this, we'd set it equal to x and put it in its other form. Okay, in its other form, this would say 7 to the x equals 25. Now you can log both sides. So we'd get x log 7 is going to be equal to log 25. And divide by log 7. Okay, so if you're going to do that, we would go log 25, close it up, divide by log, where'd log go? Log 7, and see that you get the exact same answer. So you can see the 25 is this number that's being logged, and the 7 is the base. So in general, if you have log base b of a number, you can just log the m and divide by log of b with any base. So log the 25, log the 7, divide. So if you don't have a new calculator and you want to do this, you can just go log 30, close it up, divide by log, 5, boom, and you can do it just as well with that. So a little shortcut for you. Have a great day.